Dear GATE aspirants, welcome to Veda GATE Academy. In this session, let us solve some important previous GATE questions on sinusoidal steady state analysis, dears. Let's have a look into questions. The very first question given, yes, input voltage Vin is 100 sin pi t for 100 pi RC equals to 50. VR average is dash. Please have a look into structure, dears. What is the data given? For input voltage 100 sin pi t. What is this 100, sir? Maximum value. Maximum value. What is this 100 pi, dears? Omega. 100 pi is omega. So here this 100 pi is omega. Omega RC given as how much? 50 for us. Omega RC is given as 50 for us. Now have a look at the circuit. Yes, let me compress this. Let me compress this, or okay, yeah, fine. Come on, yes, tell me, for positive half cycle, which diode is forward biased and which diode is reverse biased? Come on, tell me, sir. Positive half cycle, yes, here plus, here minus, here plus, sorry, here plus, here minus. Positive is connected to anode, negative is connected to cathode. This diode is a forward biased. Whereas here plus, here minus, this diode is reverse biased. This diode is reverse biased. Now you tell me, sir, this diode is completely forward biased. How this capacitor is connected to this voltage source? In parallel. In parallel or not? Having any doubt? Let us try to calculate what is this voltage. Put plus here, minus here. Started positive, go to negative. Go like this. Okay, 0. Here, 0. Here, V in. Means this capacitor charges to a voltage of V in. Positive half cycle. Positive half cycle. Okay, sir. Now, observe carefully, please. Observe carefully. This diode is reverse bias. Reverse bias means, can I replace with open circuit? Yes. Can I replace this with open circuit? Let me copy this 4 more times, sir. I require a copy of this. Okay. Hope I have copied. Yeah. Now you tell me, reverse bias, this diode I can replace with open circuit. This is completely open, 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 open. The structure appears like this. The structure appears like this. Now, whatever the voltage this capacitor is having, this voltage will divide between this resistor and this capacitor. Whatever the voltage this capacitor is having, this voltage gets divided between this resistor and this capacitor. Hope you agreed, yes. Series RC circuit, sir. Yes, current comes like this and it divides. So if you are having any doubt, okay, let me draw some simple DC structure. Yeah, 10 volts, 10 volts, 2 resistors connected like this. Now tell me, what happens? 2 ohms and 3 ohms. What is voltage across this? 10 into respect to 2 by 2 plus 3. Yes or no? Similar structure, yes. Getting the point, sir? Fine. You please tell me this voltage divides between this resistor and this capacitor. I can replace capacitor with what? Replace capacitor with minus J by omega C. Minus J by omega C. Now, let me compress this and write for positive half cycle. For positive half cycle, okay, diode D1 is forward biased, D2 is reverse biased. Top capacitor charges to supply voltage, and this voltage, this VTG means voltage. Let me slide this up. This voltage divides between OR and bottom capacitor. Hope you accept with this statement, yes. Come on, sir. Yeah. Can you tell me what is a V naught average, or what is this V, sir? I'm writing this V equals to, what is V in given? What is V in given? 100 sine pi t. Okay. Let me put this here. Yeah. 100 sine pi t. You can write as 100 and angle 0, phasor form. V in phasor form. V in phasor form is simply 100 and angle 0 ds. Correct or not? Next. Minus J by omega C. Okay, sir. Writing here. Voltage V equals to 100 angle 0 means simply I can write 100 into RC circuit. Respective resistance R by total resistance R minus J by omega C. R minus J by omega C. Okay, sir. Go to the point. From this, what I can write? Yeah. From this, what I can write? 100 into R. 100 into R by omega CR. Omega CR minus J into omega C. Into omega C. What is omega CR value given? 50, sir. So here I can write 100 into 50 by 50 minus J. 50 minus J. Positive half cycle, this is what the voltage here, which we got in terms of phasor form. Okay. Now let us go with negative half cycle. Negative half cycle, where we are written, yes, structure, it is here. Negative half cycle, you please tell me. Negative half cycle, black color pen, yeah, fine. Negative half cycle, this is plus and this is minus. Now what happens, sir? This is plus and this is minus, what happens? This minus comes here, plus will be here, minus comes here, plus will be here. Let me erase blue color pen. Yeah. This blue, let us erase. You tell me please, which diode is forward biased now, which diode is reverse biased? Come on, sir. What happens now? This diode is reverse biased. This diode is forward biased. This is forward biased. What is voltage across this capacitor? Started positive, go to need how much? V in. Started positive, go to need how much? V in. Okay, sir. Started positive, go to negative. Sorry. V in. Now, this bottom capacitor has charged fully. Whatever the voltage this capacitor is having, this voltage will get divides between this capacitor and this resistor. Come on, sir. Yes. Two as like earlier. Same two sources. Now first capacitor, next resistor. V0 I can write as R. For negative half cycle, V I can write as supply voltage. Same. 100 and angle 0 into 100 into respect resistance. R by total. R minus J by omega C. Replace this capacitor with minus J by omega C. So what you will be getting totally? 100 into same 50 by 50 minus J. 50 minus J. Okay, sir? These are what the values which you got in terms of phasor form. That is in trigonometric form. Calculator. Mode 2. Yes. 5000 divided by 50 minus I. Shift 2, 3. Yeah. 99.98. I am writing DS. Here I am writing. V I am getting as for negative half cycle only, sir. For negative half cycle, VR I am getting as 99.98 at an angle 1.145. For positive half cycle also same value. Negative half cycle also same value. Come on, dears. What is this value? Is it RMS or maximum? Maximum, dears. Why maximum, sir? We have not divided the supply value with root 2. Have we divided with root 2? No. Compress this. Have we divided that 100 with root 2? No. So this is your maximum value. Can you write in trigonometric form? Total VR of T I am writing in trigonometric form, sir. For both the positive half cycle, negative half cycle. Yes, if you ask me separately, I can write how much? 99.98. 99.98. Sine of how much? 100 pi T plus 1.145 degrees. Yes. So hope you tell me, please. Hope you observed. You tell me, what is the direction of current in positive half cycle as well as negative half cycle? Downwards. Earlier, sir, even here, yes, please, downwards. Even here also, downwards. Finally, what I can write is, yes, output voltage across resistor is a half wave rectified output like this. This is pi, this is 2 pi, this is your omega t, this is your VR of t, where the peak value is how much? 99.98. What is asking for? What is asking? Average. Have a look into question. VR average is dash. Come on, you all know this. You know, I know, we all know. What is the average value for full wave rectifier? Yes, please. Full wave rectifier. What is the average value? V average equals to 2 Vm by pi. 2 into 99.98 by pi. 99.98 into 2 divided by pi. Yeah, 63.64 volts. 63.64 volts. Hope you got the point, yes. Okay, right. So you tell me, please, what is the important point in this question? First, this capacitor. Yes, where's the positive half cycle? Let me go to the positive half cycle case. Positive half cycle, this capacitor will charge to supply voltage. This capacitor will act like a source for the series RC circuit. Yes or no? Next, in the second case, what happens? What happens, dear? Now, this capacitor gets charged to supply voltage. Now, this capacitor acts like a source for this series RC combination. Got the point, dears? Right. Imported model, sir. Next cue. Yeah. This is what the question given. All these are previous gate questions, dear. Okay. What is VAB average? What is VAB average? Yeah. Positive half cycle. Please tell me. Positive half cycle, what happens? Positive half cycle, here plus here minus means, yes, current comes like this. No current flows here, dear. Plus here, minus here. This diode is reverse bias. This diode is forward bias. Current comes like this. Current flows through the capacitor. Current enters the supply voltage. Positive half cycle. Whereas negative half cycle, here plus, here minus. Positive means here positive, here negative, sir. Here positive, here negative. This diode is what? Reverse bias. What about this diode, sir? Forward bias. Current comes like this. Current in this direction is what? 0 amperes. Current in this direction is 0 amperes. Current comes and enters negative terminal of the supply. Positive half cycle, what is the current direction? Current comes like this. Current flows through this diode. Current flows through this capacitor. This capacitor gets charged. Negative half cycle, current comes like this. Current flows through this diode and current enters into negative terminal of the supply. You tell me, only positive half cycle, this capacitor is getting charged. Let me write that point over here with the help of blue pen. Only in positive half cycle, capacitor is getting charged. Capacitor of what value, sir? 0.5 microfarad. Reason we have two capacitors, na? To avoid confusion, let me write the value of capacitor. 0.5 microfarad capacitor is getting charged. Through D2. Okay, sir? Right. Yes. Let me put that voltage, or first what is the VAB, sir? What is VAB? Yes, if you observe, positive half cycle, now I am doing some modification. Let me erase this. Why? Because this diode is not required for me. I am erasing this diode. Now you tell me, sir. Already we have learned this. This diode is short. Two capacitors are connected. We have to go with voltage division. What is VAB? 50 sin omega t. What is this 50? Maximum value. I am not writing any phasor form, sir. Or if you want to write phasor form also, you can write. Let me write 50 at an angle 0 degrees. What is this 50 ds? Maximum. Only when calculating power, we'll go with RMS value ds. Huh? 50 into, okay, minus j by omega c or here. Yes, what about this? 50 into minus j by omega c, or how shall we do this? As omega is not given, if omega is given, we convert into ohms. When we write in ohms, we go with respective ohmic value by total ohmic value. Here omega is not given. Let us go with voltage division of capacitors. I repeat my statement. If omega is given, we write this in ohms, Once they are in ohms, obviously voltage division means respective impedance by total impedance. As omega is not given, we can't write this value in terms of ohms. Let's go with voltage division for capacitors exclusively. Total voltage into opposite capacitance by total capacitance. 50 into, okay, opposite capacitance. 1 microfarad by total 1.5 microfarads. How much, sir? 50 by 1.5. Calculator? Yeah. 50 divided by 1.5. 33.33 volts. 33.33 volts. This is what your VAB is. What is 33.33? Is it maximum or RMS? It is maximum. Now let me draw the waveform. Only in positive half cycle capacitor gets charged. Negative half cycle 0. Positive half cycle again it gets charged. What is this? Omega t. What is this? 33.33. This is your VAB. Yes. VAB. Come on, sir. What is V average or VAB average? Since the exam asks like VAB average equals to half wave rectifier. Come on, how much? Half Vm by pi. Full 2 Vm by pi. So here just it is Vm by pi. 33.33 by pi gives you the answer. What is this? 33.333 divided by shift pi. 10.61. Yeah. It is 10.61 volts. If examiner asks VRMS, what is VRMS? VAB RMS. 33.33 by 2. By 2 means 33.33 by 2, some 16 point something. 16.66. 16.66. Okay, sir. He has not asked VRMS. I am calculating VRMS even. Find yes. So 33.33 is your maximum value. What is average value for half wave rectifier, sir? Vm by pi. 33.33 by pi. 10.61 volts. Clear, yes? Next QDS. Even exams interest is to calculate VAB average. Diode positions has changed. Beautiful question, yes. 6 pi sine omega t is given. Diode, yes. Here is asking what is the value of VAB. Let me copy the structure for one more time. Yeah. For both positive half cycle, negative half cycle, it will be useful. Come on, sir. Positive half cycle, you tell me. Here plus, here minus. This diode is forward biased. Next, say some current flows like this. Assume some current is flowing. When current enters into element, plus, leaving, minus. This diode is what? Reverse bias. Now what is the conclusion? Current is flowing, but how much value? 0 amperes. Okay, sir. Getting the point. Students used to get some doubt. Sir, diode putting forward bias, negative bias. Yes, it is a bit difficult for us. If you are having such doubt here, at this node what happens? Current gets divided. Say some current coming like this. Current entering means plus, leaving means minus. Say some current flowing like this. Assume some current is flowing. Nothing happened. You don't get any shock, right? Okay. Current coming like this. Plus here, minus here. Okay? Yes. Now you are feeling positive connected to cathode, negative connected to anode. Obviously it is reverse biased. So now current comes like this. At this point, what is the conclusion? Current in this direction is what? 0 amperes. So whatever the current that is coming, at this point that current gets divided between this and this. Now you tell me, sir, Can you tell me what is voltage across this resistor? Started positive, go to negative, following KVL sign condition. Is it not the same supply voltage? 6 pi sin omega t? Yes. 6 pi sin omega t, or let me write this into phasor form. If you write this into phasor form, 6 pi at an angle 0, here the voltage is what? 6 pi at an angle 0 volts. Voltage across capacitor. Now this voltage gets divides between this resistor and this resistor. Yes or no? Having any doubt, draw a simple series circuit, you will get clarity, DS. Okay, let me draw that for you. Let me compress this. Put this over here. Yeah. Yes, what you want? Simple circuit, right? Okay. Then that, let me draw in a similar shape. Similar shape, let me draw. Yes, you tell me, sir. You tell me. This is some, say some 2 ohms. 2 ohms. This is some 4 ohms. This is some 12 volts. Yeah. How this divides? What is this voltage? Started positive, go to negative, following KVL sign condition. How much? 12 volts, right? Now, what is this voltage? This source point of view, these two are connected in series. Divides equally. 6 volts, 6 volts. Correct or not? Let me use the same principle over there. Erase this. I'm erasing this, DS. I'm erasing this. If you want to note this, you can note. This will be not available in the notes which are written by me. This is not available in the notes written by me, sir. If you want, you can take this. Okay. Fine. Right. Zoom. What is VAB? Blue color pen. VAB equals to, for what? For positive half cycle, sir. For, not for, for positive half cycle. Okay. What is VAB, DS? VAB equals to 6 pi into respective resistance. How much? 10K by total resistance 30K. Total resistance 30K. 10K one suit, 10K three suit. Totally this is what? 2 pi. 2 pi, sir. Okay? Right. So this value is 2 pi. Now let's go to negative half cycle. Negative half cycle, black color pen. Here plus, here minus. Say some current comes like this. Current flows like this. Okay. Current divides into this. Means here plus, here minus. This diode is what? Reverse bias. Some current comes like this. Divides into this. Here plus, here minus. This diode is what? Forward biased. This diode is forward biased. Let me use eraser. Yes, this diode is reverse biased. Now I don't require this. I don't require this. Yeah. You tell me, sir. You tell me. Now which voltage? Yes. Which resistor has complete supply voltage? What is voltage across this? Sorry. What is voltage across this? Started positive, go to negative, following KVL sign condition. This will be having complete supply voltage 6 pi at an angle 0 volts. How? By writing this into phasor form. What is the phasor form of this? 6 pi at an angle 0. As suggested, if you are writing the phasor form, please mention whether it is RMS value or maximum value. Then you will be getting the clarity whether you are dividing with root 2 or not dividing with root 2. If you divide with root 2, at the last you have to multiply with root 2. If you don't divide with root 2, no need to multiply with root 2. Fine, sir? Clear for you? Done. Yes, please. Tell me. 6 pi at an angle 0. Now, how this divides? Yes, see, observe carefully. Now, this current, yes, again, it comes and divides like this itself, dears. Yes or no? Having any doubt? Yes, observe carefully. Having any doubt? Draw a simple DC circuit. Draw simple DC circuit. Yes, this is some 12 volts. This is some 4 ohms. Not follow with these polarities, with reverse polarities. Okay, sir. Now, what is this voltage, dears? 12 volts. Now, connecting a resistance like this. 2 ohms, 2 ohms. How voltage divides? Plus minus 6 volts. How voltage divides? Plus minus 6 volts. Having any doubt? Apply KVL. 12 equals to 6 plus 6. Perfectly matched. Okay, sir. What is VAB? For negative half cycle. VAB equals to 6 pi into, come on sir, respective resistance 10k by total 20k. What is this? 3 pi. What is this? 3 pi. Positive half cycle 2 pi, negative half cycle 3 pi. Check it. Positive half cycle 2 pi, negative half cycle 3 pi. Let me write the trigonometric form for this. What is VAB of t? What is VAB of t? This 2 pi is also maximum value, na? Right. 2 pi, okay, sine, what are the frequencies here? Omega t. Is there any phase difference? No phase difference. Next, plus, negative half cycle, 3 pi, this is for positive half cycle. Positive half cycle, negative half cycle, 3 pi, sine omega t minus pi, sir. Omega t minus pi. Why minus pi? Observe carefully. After pi degrees only. After 180 degrees only. Yes, I am getting second voltage here, na? Yes or no? After 180 degrees only, this 3 pi phase with this 3 pi magnitude will come. Peak amplitude will come. So, I can draw this waveform like this. How I can draw this? Yeah, this is for negative half cycle. See, I can draw this waveform like this, dears. Positive half cycle up to 2 pi. Negative half cycle up to 3 pi. Positive half cycle up to 2 pi. Negative half cycle up to 3 pi. Omega t, pi, 2 pi, 3 pi. What is this? VAB of t. What is this magnitude? 2 pi. What is this magnitude, yes? 3 pi. What is this magnitude, sir? 3 pi. What are the points? Getting the point, yes? Right. Come on. Tell me. What is VAB of t? What is VAB average? What is time period of the waveform? Time period is till 2 pi, sir. 2 pi. Till 2 pi. Okay. 1 by 2 pi. Okay. Integral 0 to pi. Integral 0 to pi. What is the function? 2 pi sine omega t d omega t. Sine omega t d omega t plus pi to 2 pi. Pi to 2 pi. What is the amplitude? 3 pi. See, here I have written the function. Here the function is there. What is that? 3 pi sine omega t minus pi. Put the same function here. 3 pi sine omega t minus pi. Omega t minus pi. Getting the point, sir? Right. Now you please tell me, sir, what is the, yes, for the simplification part, that's it. Let me put this here. Yeah, the top. Let us start simplifying this equation. Okay, sir? Fine. What happens? Equals to, yes, please, 1 by 2 pi. 2 pi into, what is integral of sine omega t? Minus cos omega t. Minus cos omega t. Limits 0 to pi. Next, plus 3 pi times, what is integral of sine omega t? Yes, even we can write that directly itself. Let me put d omega t over here. D omega t. Yes. Even with the help of mathematics, we can write this directly. Write integration ds. 3 pi into cos omega t minus of minus cos omega t minus pi. Limits pi to 2 pi. Outside you have 1 by 2 pi, sir. See, further simplifying this, just simplification part, that's it. 1 by 2 pi. 2 pi into minus cos pi is plus 1. Here minus cos pi. Let me write out minus cos pi plus cos 0, where this value is 2, sir. Plus 3 pi times, yes please, 3 pi times minus of 2 pi minus pi, minus cos pi minus cos pi plus cos 0. What is value? 2. What is value? Sorry. What is value? 2. 1 by 2 pi. 2 2's. 4 pi plus 2 3's. 6 pi. Simply the answer is 1 by 2 pi this. Simply the answer is 5 volts. 5 volts. Sir, if we have a look into structure, positive half cycle, getting the voltage. Negative half cycle, getting the voltage. It's single step. Plotting the waveform, yes, single step. Calculating average value, yes. Since it includes some mathematical equation, calculating equation, solving the equation, taking a bit time. Fine, sir. But still, if you observe, yes, we don't struck at any point. Easily, step by step, we are getting the answer. The answer is 5 volts. Please, sir, please, sir. Okay, I understood. You're eagerly waiting for homework. VAB RMS is dash. Try for VAB RMS, dears. Try for VAB RMS. Okay, will you try? Just try it, dears. Okay, next Q, please. Next Q, this is negative half cycle, right? Yeah, this is what the question. What is VAB average? Can anyone of you give the answer? Yes, pen not required, sir. What is VAB average? Yes, please. How we can do this problem? First, have a look into structure. What is this? What is source, sir? Yeah, DC source. What is source? AC source. DC and AC. Means obviously the frequencies are different. DC source 0, AC source whatever the omega that is given 5000. Frequencies are different. When frequencies are different, use only what? SPT, superposition theorem. Okay, right. Means activate this source, deactivate this source. Next, activate this source, deactivate this source. You will be taking some 10 minutes of time. V average you will be getting. But in 1 second we can answer V average. How? How we can answer V average? Sir, hope you remember. In the earlier session, we have given A0 plus A1 sin omega t. Mathematical functions. MFNs I have written. A0 plus A1 sin omega t. Come on, tell me. What is average value of this? Suppose if f of t is, yes. What is f of t average? Simply A0, na? Simply A0. Average value ready only because of DCD, yes? Come on. When your expression contains both DC and AC terms, what is average value? Simply DC term only, right? So that basic point of mathematical functions average concept, I will be using here. Fine, dears? Right. Tell me, sir. For a DC supply, activate this and deactivate this. For a DC supply, yes. What is the average value? Replace capacitor with what? Open circuit. Why you replace with open circuit, sir? So repeatedly I am telling this. I equals to C dV by dt. Means here voltage is constant with respect to time. Voltage is constant with respect to time. Change in voltage is 0 volts, though we have change in time. Though there is change in time, change in voltage is what? 0 volts. One change in voltage is 0 volts. 0 by dt. I is 0. Current 0 means replace with what? Open circuit. Current 0 means what? Replace with open circuit, dears. Getting the point, sir? Fine. Yes, please tell me, sir. I value replace with open circuit. Okay, let me use eraser. Replace this with open circuit. Once replace this with open circuit. Sir, this source is deactivated. Deactivated means replace with what? Short. Replace with what? Short. What is VAB? Inductor replace with short. Yes, VAB. Come like this. Here current is what? 0 amperes. Why? Because open circuited. Come like this. 5 volts. This ground both are same. Come like this. Go like this. VAB are reading as how much? 5 volts. So VAB average is what? 5 volts. Or, okay, let me write VAB first. VAB 5 volts. Okay, sir. VAB because of AC. Not required, but it's an example. VAB because of AC. Let us say VAB because of AC. 1 second, sir. VAB because of AC. Suppose you got VAB because of AC, some A sine 5000 T. A sine 5000 T, some plus R minus theta, say 5 plus this A naught plus A1 sine omega T. What is average value? Simply A naught. What is average value, sir? Simply it is A naught. Getting the point, yes? Fine? Right. So this is what the question. Gate exam question here. Previous gate exam question. How you are answering? Without putting pen, single step. Okay. VAB average. VAB average. Average value we get because of DC. Yes. What is this? Only because of this we get. For DC, capacitor open, inductor short. Start at A, go to B. We got as 5 volts. Because of AC, you calculate. Waste 10 minutes of time. Still, average value for AC supply is 0, not here. Why? Because why average value for AC is 0? Area of positive half cycle equals to area of negative half cycle. Area of positive half cycle, area of negative half cycle. Symmetrical waveforms. Average value is 0. We have clearly proved. So, suppose for the same question, if VAB is asked, VAB average is asked 5 volts. If only VAB is asked, even for AC supply, whatever the resist or reactive drop you are getting, that we have to calculate. Let us do that. Okay, extra question I am giving. What is that extra question, sir? If VAB is asked, what we have to do? Right. Let me erase this. So I am erasing all this. Yeah. I am erasing all this. Please wait for a second. Right. Fine, sir. My question is readily available for me. Let me put capacitor over there. Let me put capacitor. Yeah. For a DC supply, we have the value readily with us. Now let us go with AC supply. If VAB is asked, how to do the problem? Let me erase even this average over here, sir. Yes. Even I am erasing, what is this? Average. If VAB is asked, how to do the problem? How we do, sir? Looking into circuit, yes, we have two sources. Frequencies were different. When frequencies are different, use only SPT. Activate this, deactivate this. Activate this, deactivate this. What is VAB we will be getting, sir? 5 volts. If you activate this and if you deactivate this, VAB you will be getting as 5 volts. Next, activate this and deactivate this. Activate this and deactivate this. Now you please tell me, sir. Activate this, deactivate this. AC source is activated. Replace L with J omega L. C with 1 by J omega C. L with J omega L, sir. J into, what is omega ds? 5000 into 1 into 10 power minus 3. How much? It is simply J5 ohms. Whereas capacitive reactance minus J by omega C. Let me write here. Minus J by omega C. Omega 5000 into C value 1 into 10 power minus 6. Let us calculate this, sir. Let us calculate this. 1 divided by, okay, 5000 into 10 power minus 6. 200 ohms. 200 ohms, as all are in kilo ohms. Let us write this as minus J 0.2 kilo ohms. 200 ohms, sir. 200 ohms can write as 0.2 kilo ohms. Obviously correct. Into 10 by 10. I am doing. Fine. Minus J 0.2 kilo ohms. Let me write here. Minus J 0.2 kilo ohms. Now observe. Everybody please observe carefully. What is VAB because of AC source? What is the VAB because of AC source? For AC source with the given polarities, current flows like this, sir. Current flows like this. Current is flowing like this. But what is VAB? Started A, go to B like this. Direction of travel is like this. Current is flowing like this. Direction of travel branch current opposite, sir. Opposite means obviously we can put what? Minus. We are putting minus. Writing this into phasor form. 5 pi at an angle 0. 5 pi at an angle 0. Come on, tell me what you get. 5 pi into minus j 0.2 minus j 0.2 kilo ohms by minus j 0.2 kilo ohms by total ohmic value, total impedance value 1k plus 2k 3k. Next plus j5 minus j 0.2 minus j 0.2 kilo ohms plus j5 ohms minus j 0.2 kilo ohms. Come on, yes. How shall we solve this? If you proceed further, you will be getting the value, sir. Minus of minus, it is a plus 5. Minus of minus, it is a plus 5 pi. 5 pi into 0.2. 5 into pi into 0.2. It is simply pi, dears. This is simply pi. So, pi into 10 power 3 by, sir, just have multiplied 5 pi into 0.2. 5 into 0.2 is 1, sir. Perfectly 1. Okay. Pi into this k is 10 cube by 3k denominator 3000 minus 3000 not minus dear plus 3000 plus 5i minus 200 5 minus 200i. Yeah. It is 3000 minus 195i. 3000 minus 195i. Whether even here we have I term, that I term has to be mentioned, which is simply j, sir. We represent like j. Let us represent that j. Now the expression is perfectly correct. I repeat. See, pi is here. 10 power 3 is here. This j is here. 3000. Yes, 200 minus 5. Simply it is 195. So let us substitute this. 1000 shift pi into I divided by 3000 minus 195i. This value in terms of phasor form 1.044 you get. Yeah. You will be getting as 1.044 at an angle 93 points. 1 second, one more time. 93.71. 93.71 degrees. What is 1.044? Maximum itself, sir. Finally, what is VAB? We can write 5 plus, okay, 1.044. 1.044. What is the function? Sine 5000t. Sine 5000t plus, what is the angle you got? 93.71. 93.71 degrees. So this is what your VAB is. Okay. Please sir. Okay, understood. You want some homework. This is what VAB, sir. Let us calculate what is VAB RMS. Even for this function, you tell me what is VAB average? Simply 5 only, na? After doing this much calculation, what is VAB? A0 plus A1 sin omega d. What is average value? A0 only, which is simply 5. Okay, dears. Fine. So, what is VAB RMS? Root over 5 square plus 1.044 square by 2. Okay, sir? Simple, single step. Done, dears. Next Q, sir. Next Q. Simple, sir. Yes. V of t is 12 sin t. He is asking for IRMS. IRMS. Okay, sir. Fine. Tell me. What is average value? What is average? Let us calculate both average as well as RMS. Average means only for DC supply. How much? I average is simply 8 amperes. Inductor behaves like short, na? What is IRMS? That is important. Anyhow, we got this. Activate this source. Deactivate this. Simply I, because of DC, got as 8. Next, with the help of a black color pen, what is this value given? 12 sin t. Omega is given as 1. This will be what? J1 ohms. What is the phasor form for this? 12 at an angle 0. What is I RMS or I because of AC? I because of AC we should write like this. How much? 12 by, come on sir, 1 plus J1. How much? 12 by x plus jx root 2, x root 2, 1 into root 2 at an angle 45 degrees. Means how much? 6 root 2 at an angle minus 45 degrees. 6 root 2 at an angle minus 45 degrees. So I can write my overall current expression as 8 plus, okay, 6 root 2 sine t minus 45 degrees. This is your current expression. 8 plus 6 root 2 sine t minus 45 degrees. What is IRMS? Frequencies are different. Use square root form. Individual RMS square. 8 square plus 6 root 2 whole square by 2. How much? Slide this up. Root over 64 plus 36 into 2 by 2. How much? 10 amperes. IRMS is 10 amperes. Fine, sir? Done. Next Q, dears. Next Q. For what value of C? Exam has not given the question here. Let me write that question. For what value of C? For what value of C, current I is 0. For what value of C, current I is 0, dears. Okay. Current I 0 means, here what happens? This voltage equals to this voltage. Current I equal to 0 amperes. Sir, if you take this as the reference point, what is this voltage? Here this is 0, na? So, if you represent 5 sine, if I can represent phasor form, it is simply 5 pi at an angle 0 volts only, na? Even here, what is this? Same 5 pi itself. Clear? Current 0, dears. Current 0 means, yes, what is this voltage here? Start here, go to ground. 0 into this reactance, 0. 0 into this 0. Current into ohms is 0 only, na, sir. When current is 0, current into ohms, which is voltage, also 0, na? So here 0 voltage plus 5 pi voltage. Same 5 pi voltage is here. Fine. Now, how to get this? Yeah, C value required. Omega is given. How much? 5000. J omega, sir. How much? J 5 ohms. Even here, what is this? J 5 ohms. Minus J by omega C. Minus J by omega C. Let us substitute omega at the last. Let me compress this. Compress. Put this here. Let us apply KCL, dears. Sigma leaving equals to 0. By KCL, sigma leaving equals to 0. What is leaving current? 5 pi by J5. This voltage minus this voltage by J5 plus 5 pi, 5 pi. Next. 5 pi minus 0 by J5 minus J by omega C equals to 0. Equals to 0. First 5 pi gets cancelled, sir. 5 pi gets cancelled. It goes to denominator, sir. 1 by J5, okay, plus omega C by, plus omega C by, why? Because omega C goes to numerator. J5 omega C minus J equals to 0. Equals to 0. Take this 1 by J5 to other side. What I can write? Omega C by J5 omega C minus J equals to minus 1 by J5, which is simply I can write as J by 5. Sir, this goes to other side. Minus 1 by J5, which is plus J by J5. Now, let's go with the cross multiplication, dears. Let's go with the cross multiplication and easily we can get the value of C. Do this calculation on your own if possible. C value get as 20 microfarads, dear. C value we get as 20 microfarads. Okay, 5 omega c. Let me do this. Whatever best I can do for you, I will do it. 5 omega c equals to j square minus 1 minus 5 omega c. Minus 5 omega c. I repeat, sir. J square minus 1 minus 5 omega c. Yes. J plus 1. Minus j square means plus 1. 10 omega c equals to 1. What is c? 1 by 10 omega. 1 by 10 into, what is omega given? 5000, right? 1 by 50,000. Perfectly 20 microfarads. 1 divided by 50,000. 2, 3, 4. Yes, 2 into 10 power minus 5, which is 20 microfarads. Find yes. Next Q, please. Yeah, V1 value given, V2 value given, V3 value given, and he's asking for the value of this I. Interesting. Even students used to do a lot of mistakes here. Okay. Answer will get some 173.2 at an angle 120 degrees, sir. Please tell me, apply KCL over here. Okay. I want the value of I, V1, V2, V3 given. Can I compress this and put this here? Hope the screen is stable, yes? Fine. Sir, let us apply KCL at this node. All these are single node, yes? Huh? Single nodes. Okay. To apply KCL, let me take this as the reference point. So, obviously, this voltage is what? 0 volts. This voltage is what? 0 volts. Okay, right. Entering current is I. What is this potential, sir? What is this potential? Start here, go to ground. Minus V2 plus V1. Can you go to ground like this? No, not possible. You can go like this. Minus V2 plus V3. How much? Minus V2 plus V3. Next, what is this potential? Start here, go to ground. How much? Minus V1 plus V3. Minus V1 plus V3. Minus V1 plus V3. Entering current I equal to leaving current in this direction and in this direction. Entering equals to leaving, sir. Entering current I equals to leaving current. This minus this by J1. This minus this. When you are doing minus, V2 minus V3. V2 minus V3 by J1. Sir, please understand what I am doing here. 0 minus this. Or you want me to write? Okay, let me write here. For better clarity purpose. Otherwise, you may feel 0 minus of minus V2 plus V3 by J1. Okay, next, what is current in this direction? 0 minus of minus V1 plus V3. Let me slide this down. Logo may disturb you. Minus V1 plus V3 by J1. Further simplification, sir. V2 minus V3 by J1 plus V1 minus V3 by J1. V1 minus V3 by J1. Sir, here it is minus J1, right? Yeah, this is minus J1. Therefore, this is minus J1. V3 by J1, V3 by minus J1. What happens? Pencil. V3 by J1, V3 by minus J1. Pencil, sir. Sir, minus of minus plus. This is plus, this is minus. Plus 1 minus 1 cancels. Obviously, what is I? V2 by J1 plus V1 by minus J1. What is V2 given? 100 at an angle minus 120. 100 at an angle minus 120. 100 at an angle minus 120 minus 90. How much? Minus 210 degrees. Plus, what is V1 given? 100. This minus 90 goes numerator, plus 90. 100 at an angle 90. Open the calculator. 100 at an angle 90 plus 100 at an angle minus 210, shift to 3, 173.20 at an angle 120 degrees. Okay, as said, 173.2050808. Sorry, how by hearted, not giving the values. I got DS. Okay, right. So even you try, you will get the same. Okay. at an angle, how much? 120 degrees. Let me slide this up. This is your I. Find yes. Many people said, then cancelling these two elements. Keep on substituting the values, wasting a lot of time for getting the answer. When they're getting cancelled, make expression always simple, dears. Okay? Let's go to next cube. One more simple question. Yeah. I1 of t given, I2 of t given. Exams interest. I3 of t is dash. Compress, simple question. Let me put this here. So let us apply KCL over here. Sigma of entering equals to 0. By KCL, sigma entering currents equals to 0. E means entering. I1 of t plus I2 of t plus I3 of t equals to 0. Exam's interest is I3 of t. What is I3 of t, sir? Minus I1 of t minus I2 of t. What is I1 of t already given? Minus sin omega t. Minus of minus plus sin omega t minus, what is I2 of t? Cos omega t. Cos omega t. Convert either sin into cos or cos into sin, your wish. Let us convert this cos into sin, ds. Yes. Sin theta plus or minus 90. How much? Plus or minus cos theta. I have plus cos theta, I want plus sin. It means plus 9 theta. 90 degrees. Minus sin theta plus 90. Sin theta plus 90. Yes. Or, sir, we have minus cos theta, na? See, we have to think like this. We have minus cos theta. You have to go with what? Sin theta minus 90. Obviously, this will become plus. Plus sin theta minus 90. Sin theta minus 90. Okay. Writing this into phasor form. 1 at an angle 0 degrees plus 1 at an angle minus 90 degrees. Which is simply 1 minus 1j. What is 1 minus 1j, sir? Root 2 at an angle, how much? Minus 45 degrees. Root 2 at an angle minus 45 degrees. Hope you got the point. Writing into trigonometric form, I3 of t equals to root 2 sine omega t minus 45 degrees. This is your I of TDS. Root 2 sine omega t minus 45 degrees. Okay. 1 minus 1j. Yes, x minus jx, obviously x root 2 at an angle minus 45 degrees. This is your I3 of t. Next question. Simple question, sir. A bit fastly we can do. Compress this. He is asking for the value of VL. Sufficient data is given. What data is given? VR is given. Okay. VC is given. This current is given. He is asking for VL. What is VL? Already studied in DC analysis. L di by dt. L di by dt. Sir, to this node, 4 branches connected. 3 currents were given. 4th current can be easily calculated. Once you get 4th current, V equal to L di by dt. You will be getting the value of VL. Clear? Right. Please tell me, sir. KCL in AC analysis, I can say like this. VC value given 4 sine 2t. VC value given. Sir, polarities will confirm current is flowing in this direction. What is this IC? You tell me this IC value first. IC equals to C dV by dt. What is VC given? C dVC by dt. What is VC given? C value is 1 into, what is derivative of this? 4 into, what is derivative of sine 2t? Cos 2t. Cos 2t into 1 more 2 here. Therefore, 8 cos 2t ds. Fine? Okay? Right. So, we got this current. Now, apply KCL, sir. By KCL, entering equals to leaving. What is entering current? 2 amperes plus, what is VR value given, sir? 5 volts. What is this current? 1 ampere. Okay. So 2 plus 1 equals to leaving current IC 8 cos 2t plus let us say some IL current is flowing like this IL. Finally, what is the expression for IL? 3 minus 8 cos 2t. This is what the expression for IL. Once you have expression of IL, what is VL, sir? L di by dt, na? Yes. Derivative L value how much given? L value given as how much? 1. 1 into, what is derivative of this? 0 minus 8 into, what is derivative of cos 2t? Minus sin 2t into 2. Into 2. How much total it is? 16 sin 2t volts. Okay. Lot of points involved. But doing this problem, simple yes. VR given, VC given. Okay. Calculate current through inductor. L di by dt gives you the value of VL. Have a look in the question, please. Fine, sir. Is it okay for you? Yes. Right. Let's go to next Q. This question, examiner's interest is to find the value of phi. Some more data also given, sir. If IL of 0 equals to 1 amp, IR of t equals to 4 e power minus 3t plus 3 e power minus 4t, then phi equals to dash. Then phi equals to dash. So current directions were clearly given. Let us apply KCL. How I can apply? Entering current IL of t plus other entering current 12 cos omega t minus phi equals to this entering current plus this entering current equals to leaving current. How much? IR of t, sir. But he has clearly given IL of 0 as 1 amp. Substitute 0 over here. IL of 0 plus 12 cos phi equals to IR of 0. What is IR of 0? This is 0, sorry, e power minus 0, 0. E power minus 0, 0. What is this value totally? 7. So here I can put IL of 0 given as 1. 1 plus 12 cos phi equals to 7. What is the value of phi from this? 60 degrees. The value of phi is perfectly 60 degrees, dear. Have a look. Simple, sir. Previous gate questions. Simple. Almost all the questions, gate questions were designed in such a way that maximum we can do the problem in 1 minute, yes. Okay? Right. 30 seconds to hardly 180 seconds, dear. That's it. We can do the problem. They were designed like that. They were designed like that. Please understand my phrase. Next QDS. Yes. Come on, sir. This is what the structure given. Can we do this? What he has given? Understand? Till now we have done some problems. With that knowledge, let us analyze how we can do this problem. Source is given. This capacitor is given. This is given. He is asking for the value of V0. Yes, we have to if this omega is given, either this star, this delta or this delta convert to star. This delta or this delta convert to star. Okay. Convert to star, find total current, again current division, do the problem. You will take 1 day time. Examiner has given some other data here. What is the data? Under high frequencies, if supply frequency is very high, if supply frequency is very high, peak output voltage is dash. Peak output voltage is dash. This phrase is given by the examiner. Okay, right. See, since this phrase is given by the examiner, how fastly we can do the problem. Observe, yes. What is capacitor is given now? What is capacitor reactance? Xc, sir. Xc equals to what? 1 by omega c. In short, even I prove this. How Xc is 1 by omega c, sir. If frequency is high, Xc is less. Xc is less means approximately we can take as 0 ohms. 0 ohms means what, sir? Short circuit. This capacitor I can replace with short circuit. This capacitor also I can replace with short circuit. Once I replace this with short circuit, you tell me 1K into 1K equals to 1K into 1K. Bridge balance. Perfectly bridge is balanced, yes. Bridge is bridge here. Bridge is balanced, not bride. Huh? Perfectly bridge is balanced. Okay, sir? Right. Once bridge is balanced, what is the value of V0? Simple, sir. When this is short, these two are in parallel, these two are in parallel. 0.5K, 0.5K. Whatever voltage that is there here, even here also same voltage. Na? Across the parallel combination also same voltage. So, what is this voltage? If you write in phasor form, 1 at an angle 0. So, what is this one, sir? Maximum value. Maximum value. Voltage divides equally. Let me use black color pen. So, this V0 will be what, sir? Half at an angle 0. Even here, if you ask me what is the voltage, half at an angle 0. Anywhere. Even here, if you ask me what is the voltage, half at an angle 0. Even here, what is the voltage, sir? Half at an angle 0. If you ask me what is voltage across this capacitor, 0 volts. If you ask me what is voltage across this capacitor, 0 volts. If you ask me what is voltage across this capacitor, is also 0 volts. Why? Because plus 1 minus half, 0 volts. Okay, sir. Anywhere it is 0 volts. Here half, here half, here half, here half. What is this half, sir? Maximum. Maximum or peak value both are same, na? Right. He's asking for this. What is this peak value? Peak output voltage is what? Half volt. See how fastly the problem is completed. The data given by the examiner. If capacitor is operated high frequencies, obviously its reactance is very, very less. Approximately equals 0 ohms here. Next Q. One more interesting question. Beautiful question, sir. Beautiful question. Right. Let me copy this for one more time. Yes, I require this. Yeah. Okay, sir. How shall we do this? Regular method, sir. Regular method. 1 at an angle 0 coming like this, I going like this. Current distribution. What will be current here? 1 minus I. Sir, I am telling you 1 at an angle 0, simply we can write as 1. What can be this voltage, sir? J1 into I. J1 into I. Let us try to apply KVL in this closed path like this. Direction of travel, sir. Direction of travel, direction of travel, direction of travel. What is this voltage? J1 into I, na? Started positive, go to negative. Let me slide this left. J1 into I equals to started positive, go to negative, following KVL sign convention. 1 minus I plus 1 minus 1. Sir, entering at positive, plus 1, entering at minus. See, this is minus, sir. Here plus means here minus. Entering at minus, minus 1. Plus 1, minus 1. So, here what I can write? Minus I going other side. I plus J1I equals to 1. Take I as common. I equals to 1 plus J1. 1 plus J1. What do you get, sir? 1 by root 2 at an angle 45 degrees. How much? 0.707 at an angle minus 45 degrees. This is your I. Since he asked for capital I, yes, exam's interest is capital I, sir. What is the value? 0.707 at an angle minus 45 degrees. So this is what the magnitude, sir. Okay. Phasor forms given by the examiner means obviously this could be what value, sir? RMS value. What is the other way we can do this problem? One more, even I will explain 3 methods, sir. 3 methods. Yeah. What is the other way we can do this problem? What is the other way we can do this problem? Excellent way. What is that? What is that? So now please. Sir, right. This potential. What is right? Let me take this as the reference point. Let me take this reference point. What is this potential, sir? Start here, go to ground. How much? 1 at an angle 0 minus 1. How much? 0 volts. 0 volts means this point, both the points are same, na? Both potentials are same, dears. Once both potentials are same, I can compress the 2 points. Once I can compress the 2 points, current is coming like this, getting divided into this and this. Here plus, here minus. Here plus, here minus. Positive connected here. This negative connected here, this negative connected here. As both the points are same, I can happily apply current division between these two. Now what is I? 1 into, what is opposite? 1 by, how much? 1 plus J1. Single step over. Single step over, sir. Getting the point? Or you can also think like this. You can also think like, sir, how we get this idea in the exam? Okay. You call this as A. Call this as B. Call this as C. Call this as D. Okay. Right. Call this as D. Yes, tell me, what is VAB voltage? Start at A, go to B. How much? 0 volts. 0 volts means potential difference between these two is 0. Potential difference is 0. When the potential difference is 0? When potentials are equal only, na? When potential difference will be 0? When potentials are equal. Sir, I equals to VA minus VB by R. When this I is 0, when VA equals to VB only, na? So here this is A, this is B. Find yes? Fine. So here I can apply current division like this. Yes, we can also understand few more points here, dears. What is that? Means current in this branch is 0 amperes. Current in this branch is 0 amperes. These sources are not delivering any power. Not delivering any power. So whatever the 1 at an angle 0 coming like this, here also you will be having same 1 at an angle 0. This current only coming here. This current only coming here. That's it. And no current is flowing like this. Having doubt? Okay, I will also prove like this. See, so now one more method, last method. Sir, here 1 into 1 equals to minus J1 into J1. Minus J1 into J1. Minus J square. 1 into 1, tick mark. Yes, bridge is balanced. Once bridge is balanced, yes, what are the points that you have learned in bridge balance concepts? Source should be connected to one diagonal, load should be connected to other diagonal. Yes, here source connected to one diagonal, load connected to other diagonal. Feel this as a load. Once bridge is balanced, no current flows through load, na? 0 amperes. Here also the current is what? 0 amperes. So this current is coming. Whatever current comes here, same current flows here. Whatever current comes here, same current flows here. I want current in this branch. So total current 1 at an angle 0 into I equals to opposite. How much? 1 minus J1 by total 1 minus J1 plus 1 plus J1. How much? It is simply 2. So finally, what is the answer, sir? Root 2 at an angle 45 by 2. 1 by root 2 at an angle minus 45 degrees. Cross check. You got the same answer earlier also. Same answer. How much? 1 by root 2 at an angle minus 45. Cross check. First method also got the same answer. 0.707 at an angle minus 45. Sir, in the notes which is written for you, which is given to you, I have written only this method. But the two most beautiful shortcuts. This is the best shortcut. It is not written in the notes. Have a look into video, yes. Okay. Right. Next, even this shortcut. Bridge problems, dear. In AC analysis, I am covering everything, sir. Voltage division covered, current division covered, mesh analysis covered, nodal analysis covered. Okay. Superposition covered, Thevenin's covered, Norton's covered, reciprocity theorem covered, maximum power transfer theorem covered, Millman's theorem covered. Okay. Covering almost all the bridge balance concepts covered. Okay, sir? Fine. Don't ask me source transformation and all. Source transformation, just multiplication. If current source is given, current source multiplied with impedance gives you voltage source. Voltage source by impedance gives you current source. Fine, sir. Next Q. This is what the question given, and the data given by the examiner is for what value of V? For what value of V? For what value of V? Power dissipation in 6 ohm is 0. power dissipation in 6 ohm is 0. Or power absorbed by 6 ohm is 0. Simple phrase. Blue color pen. Yeah. Sir, power absorbed by 6 ohm is 0 means I 6 ohm square into 6 equals to 0 means what is this current? 0 amperes. What is this current? 0 amperes. Let us assume some current flowing like this. Call this current as I1. Let us assume some current flowing like this. Call this current as I2. Can you tell me what is I1, sir? What is I1? Well, let me use caps here. Because given the phasor forms. I1 equals to 20 by 1 plus J1. Means root 2. 10 root 2 at an angle minus 45. So we have to write this fastly, dears. Root 2 at an angle 45. 20 I can write as 10 into 2. 2 by root 2. 10 root 2 at an angle minus 45. Next, what is I2? I can write V by 5 plus 5, 10. 0 means no current flows here, sir. Current flows like this. If here the current is I1, here the current is I1. Why? Because here 0, na? Since here 0, here the current is I2, here the current is I2. Now interesting point. Single step. Our problem is completed. How? Let me come. Sorry. Right. Let me compress this. Yeah. You tell me when current is 0, this voltage, I can equate. How I can equate? Started positive, go to negative. What is this voltage we got, sir? I1 into J1. I1 into J1 equals to, what is voltage? I2 into 5. What is I1 we got? 10 root 2 at an angle minus 45, na? 10 root 2 at an angle minus 45 into 1 at an angle 90 degrees equals to, I2 into 5. What is I2? What is I2 we got? V by 10. V by 10 into 5. 5 ones, 5 twos. Finally, what is V, sir? 20 root 2. 20 root 2 at an angle 90 minus 45, 45 degrees. All these are previous competitive exam questions, sir. Almost we are doing without putting pen. Just single steps, sir. Single steps. Okay, not taking some 5 minutes, 10 minutes like that. Fine, yes? Next. 20 root 2 at an angle 45. Next question, sir. Yes. VAB is dash. He simply is asking for the value of VAB. Come on here, simple. Pen not required. How simple it is. So now please. All these are connected in parallel. What is this voltage? 100 volts. What is this voltage? 100 volts. Now this 100 volts divides between this and this. I am asking voltage across this. What is VAB? VAB getting as 100 into respective J4 by total 3 plus J4. 3 plus J4. How much? 400 by 5. 400 by 5 is some 80. 80. Yeah, let me do this. 400I. Okay. Sorry. 400I divided by 3 plus 4I. Yeah. 623. 80 at an angle 36.86. 80 at an angle 36.86 degree volts. So these are what few previous gate problems I wish to do. Yes, with this science soil steady state analysis, yes, it is completed.